Greetings to all. Myself Vaishnavi, Assistant Professor IT Department from SNS College of Engineering. Now we are going to see about the contiguous memory allocation in the operating systems. The main memory should accommodate both the operating system and the different client processes. Therefore, the allocation of the memory becomes an important task in the operating systems. Third point, the memory is usually divided into the two partitions, one of the resistant operating system and one for the user process. We normally need the several user processes to reside in the memory simultaneously. Next, therefore, we need to consider how to allocate the available memory to the process that are in the input queue waiting to be brought into the memory. In adjacent memory allotment, each process is contained in the single contiguous segment of the memory. Here we have the diagram for the contiguous memory allocation. The empty box, a small box represent the processes, and then here we have that memory blocks. According to the availability of the memory blocks, the processes will be allocated. Next one, each process is contained in the single contiguous section of the memory. There are two methods, namely fixed partition method and the variable partition method. First one is the fixed partition method. That is, divide the memory into the fixed sized partition where each partition has exactly the one process. Next point, the drawback is the memory space unused within the partition is empty. Example, when the process size may be greater than the partition size. It is the main drawback for the fixed partition methods in the contiguous memory allocations. Next one will be the variable partition method. That is, divide the memory into variable size partition depending upon the size of the incoming processes. Next point, when the process terminates, the partition become available for the another process. Third point, as the process is complete and leave, they create the hole in the main memory. Hole, that is the definition for the hole will be the block of available memory that holes of the various sizes are scattered throughout the memory. We define that available memory as a whole. Next one will be the dynamic storage and the allocation problem. How to satisfy the request of the size is equal and from the list of free holes. Solution, we have the three fits, that is first fit, best fit and the worst fit. First fit, allocate the first hole that is big enough, mm, that comes under the first fit. Next type is the best fit, allocate the smallest hole that is big enough, must search the entire list unless ordered by the size, and produces the smallest leftover hole comes under the best fit. Third fit is the worst fit. Allocate the largest hole, must also search the entire list, produces the largest leftover the hole. First fit and best fit are better than the worst fit in the terms of specific storage utilizations. Next one will be the fragmentation. In fragmentation, we have the two types, that is external fragmentation and internal fragmentation. Here we have first one is the external fragmentation. This takes place when the enough total memory space exists to satisfy the request, but it is not contiguous. That is, storage is fragmented into the large number of small holes scattered throughout the main memory. Second type is the internal fragmentation. Allocated the memory may be slightly larger than the request memory. Here we have the diagram for the internal fragmentations. Example for the fragmentation will be the allocated the whole will be the 184 bytes. The process will be the process size will be the 182 points. Here we are left with the whole of 2 bytes, that is the size of the whole we have this 184 bytes. The actually our process size will be that 182 bytes. So we have the small space empty, that is we have left with the whole of 2 bytes. It comes under the best fit. Thank you.